Okay, in this lecture we're going to talk about some more basic functions. Again, we're using basic functions later on to actually build more complicated functions. So it's very important to understand the characteristics of these basic functions. The next one is the square root function. And you can see here that f of x is equal to the square root of x, and this is the graph of it. Now, what are the characteristics of this? Um, well, let's have a look at a table of values first. Okay, so here's x and here's y. Now, the important thing about this is that when we're taking the square root here, of course, we're going to take square root of positive numbers. So we can only put positive numbers in here. So let's start with 0. It's not positive, but we can find the square root of it. And that's, of course, 0. So the next one that's easy is 1. So the square root of 1 is 1. Remember, this is the principal square root. 2 is a bit more difficult. 3 is a bit more difficult because they're irrational numbers. So let's try with 4. Square root of 4, of course, is 2. You can see here that these are these points here. All right, 1 is here, 1, 1. And of course, 4 and 2 would be this one here. All right, so we can see here a few things about this function that we should keep in mind. First of all, what is the domain? All right, well, the domain of the function are the x values that we can use, and see we can only use non-negative values. So in other words, x has got to be greater than or equal to 0. So this would mean that we'd have 0 to infinity being our domain. The range, all right, is, of course, notice that the smallest value of y we could get was 0. After that, we just got positives. So, of course, y has got to be greater than or equal to 0 as well. So our range would be the same. Right, now the next thing is, what about the continuity? Well, you can see here that we can trace over this, over its domain, so it's continuous on its entire domain. Right, so that would be from 0 to infinity, like so. Next, when is it increasing and decreasing? Well, we can see that it's always rising to the right, so it's increasing on its entire domain again, which is this interval. It is never decreasing. All right, so that's our square root function. Now the next function we're going to look at is what's called the cube root function, where we find the cube root of the function. And of course we can have a look at some values of this. X, y. Now we're going to find the cube root, so we need to be careful what ones we choose here so we can actually find values easily. So we look for cubed values. So for example, if I tried negative 8, what number multiplied by itself 3 times gives me negative 8? Well, it would be negative 2. The next cube number would, of course, be negative 1, and the cube root of that would be negative 1. Of course, the cube root of 0 is 0, of 1 is 1, and of 8 is 2. So you can see here we have 0, 0. Right, we have negative 1, negative 1. We have 1, 1. And of course it goes up to negative 2, 8, and so forth. Sorry, negative 8, negative 2, and 8, 2. So if we went across here, that's what we would get. All right, so here again we want to look at what is the domain. Well, we can see that the domain is going to be all real numbers, because we can actually find the cube root of any numbers, whether they're positive or negative. Right, so that's going to be all real numbers. And notice that even though this is going down slowly and this is going up slowly, it will eventually keep going up and up and up forever. So the range, of course, is also all the real numbers. All right, next, what is it continuous? Well, we can, of course, it's going this way forever and going this way forever, and we can trace over this without taking our pen off, so it's continuous on its whole domain. So now when is it increasing and decreasing? Well, it's going up to the right here, up to the right, up to the right, up to the right, up to the right. So in other words, it's increasing on its entire domain. So it's also increasing on negative infinity to infinity, and of course it's never decreasing. All right, and so there's our characteristics for the cube root. Right, the next one is the absolute value function. Now remember, the absolute value means that it's really defined like this, that it's x when x is greater than or equal to 0, and negative x when x is less than 0. So if I have a positive number or 0, then I just take the number. If I have a negative number, then I change its sign so it becomes positive, because the absolute value has to do with the distance, if you like. Now, if we were to do a table of values here, x, y, and we could start with, say, -2, -1, 0, 1, 2, then the absolute value of -2 would make it negative of -2, which would be 2. -1 would be the negative of -1, which would be 1. Of 0, of course, is 0 itself. 1 is positive, so it's 1, and 2 is positive, so it's simply 2. So notice here we have -2, 2. We have -1, 1. We have 0, 0. We have 1, 1. And we have 2, 2. Right, so you can see here it forms this V shape. So let's look at the domain. What is the domain of this function? We can see here we can take the absolute value of positive and negative numbers, but we'll always produce positive numbers, so clearly the domain is all real numbers. However, the range, of course, is restricted because we only get positive numbers, and the lowest one, of course, is 0, so we really only get non-negative numbers, so we can have 0 to infinity. All right, now, is it continuous? Well, notice that we can, in fact, trace over this without taking our pen off, and it goes up here forever and up here forever, and so it's continuous on its domain, which of course is negative infinity to infinity. Now when is it increasing and decreasing? Well, notice that as x is moving towards the right, this is falling to the right, so it's decreasing. All right, from negative infinity across to 0. Like so. And of course, at 0, then it starts moving up to the right. So it's rising to the right as x goes towards the right. And so it's increasing from 0 to infinity. Okay, so that's our absolute value function. And there are another 3 basic functions.